Hi, my name is Sumit Bhatia and I am a data analyst. I have been provided a task to present a presentation to the stakeholders of an insurance company, ABC, uh, regarding the inbound call volume dataset. I have been provided with a dataset of 23 days of the inbound call center of the insurance company. So coming on to the project description. In this project, we will be analyzing a data set of a customer experience inbound calling team provided to us for 23 days for an insurance company. The customer experience team consists of professionals who analyze customer feedback and data and share insights with the rest of the organization. Inbound customer service is the methodology of attracting, engaging, and delighting the customer to turn them into loyal customers. The analytical skills will help targeting those audience which are capable of converting with a lower cost. So coming on to the approach which we followed in this project, first and foremost is the problem statement. The problem statement is as follows: analyzing the data set of a customer experience inbound calling team provided to us to help the organization improve customer experience with the products and convert potential leads into loyal customers. Now, coming on to our next step, understanding the data. We will spend some time understanding the data set provided to us with the help of data dictionary. Next, we will do some initial data analysis and then cleaning of the data, which is a very important part of data analysis. Tech stack used in this present project are MS Excel version 2010 and a Python Jupyter notebook. Python mainly we will be doing data cleaning part in Python Jupyter notebook and data analysis in MS Excel. So coming on to understanding the data. Our data set contains data for 23 days. The raw data set contains 1,17,988 rows and 13 columns. This data includes the following columns, and the data types of the columns do not require any changes as we have looked with the help of Python Pandas library. Now data cleaning. First of all, I would like to take you to my Python Jupyter notebook, in which I have done all the data cleaning. Here is my Python Jupyter notebook in which all the data cleaning has been done. These are the required libraries which have been imported. Here I am reading the data set into the Python Pandas data frame. This is the first 5 rows of the data set. This is the shape of the data. With the help of this function, we were able to find out the number of rows and columns in the initial data set. Here are the initial analysis and data types of each and every column, which does not require any computer changes. Now coming on to data cleaning part. First of all, we have checked the duplicate value treatment in the data, and our analysis shows that there are no duplicate values present in the data set. Now coming on to missing value treatment, here only wrap by column contains more than 40% of missing values which needs to be treated. Other columns like agent name and agent ID, those don't require any treatment. So we will be dropping the wrap by column as it contains more than 40% of missing values, and it will not help us in any further analysis. Coming on to outliers. Here are the 2 columns on which we have checked the presence of outliers. As we can see, the column call seconds contains some outliers. But after looking at those outlier values, we have come to a conclusion that it doesn't require any outlier treatment. So after cleaning is done, again we have written the data frame to our Excel file, which we'll be using to analyze the further data set and answer the questions asked. So here comes our clean data set. This is our data set which has been converted into an Excel table. With the help of this, we will be creating pivot tables and pivot charts for the questions asked. Now coming on to our questions asked. So our task one is as follows. We have to calculate the average call time duration for all incoming calls received by agents. For the given task, the steps are as follows, which we followed. We created a pivot table with time bucket as row labels and average of call duration as values. Applied call status in report filters and filtered out answered and transfer calls and removed the abandoned calls. Created a pivot chart with the help of the data, edited the chart title and axis titles and rounded off the data labels. I will be showing you this process in Excel. Now coming on to Excel, this is our sheet in which the analysis for the average call duration is done. Here is our pivot table and here is our pivot chart. Coming back to the presentation. So this is the graph which we achieved with the help of the pivot chart with time bucket on the x-axis and the y-axis contains the average call duration for each time bucket. The inferences and insights which we gain from this graph are as follows. The average call duration is highest between 10 a.m. to 11 a.m. and 8 p.m. to 9 p.m. Lowest average call duration is between 12 a.m. to 1 p.m. 12 p.m. to 1 p.m. I beg your pardon, with a value of 191. The average call duration is least during afternoon hours. So, coming on to our second task. We have to show the total number of calls coming in for each time bucket. Again, for this task, we created a pivot table with time bucket in row labels and count of call in values. Drag the call status into legend or column labels. Created a pivot chart with the help of this data and edited the chart axis and titles. I will show you this pivot chart and pivot table in the Excel file. Here is our pivot chart and here is our here is the pivot table and here is our pivot chart. Now coming back to our presentation so that I can provide the insights which I gained from this graph. This graph clearly shows that highest number of calls are answered between 12 p.m. to 1 p.m. Lowest number of calls are answered between 8 p.m. to 9 p.m. Highest number of calls are abandoned between 9 p.m. to 11 a.m. Lowest number of calls are abandoned between 4 p.m. to 7 p.m. Morning hours the highest number of abandoned calls. This needs to be improved by the organization. So coming on to our third task. This is a slightly complicated and lengthy task. In this task, we have to provide we have to provide the number of agents required for each time bucket so that we can achieve a target of 90% of answered calls and the abandoned calls should be less than or equal to 10% and not more than 12%. The steps which were followed during this third task is as follows. I created a pivot table with call status as row labels and count of calls, percentage of each call status and average of each call for each status as values. Created another pivot table for each time bucket with the percentage of count. Let me show you those pivot tables one by one and step by step. Here is our first pivot table which contains the call status in row labels and count of calls, percentage of count of calls and average duration of calls for each call status. Now another pivot table contains the percentage of calls for each time bucket. Here is our another pivot table. So here is another pivot table which contains count of calls in seconds for each time bucket in percentage of the actual value. Now I calculated the incoming calls per day by total number of by dividing it by dividing the total number of calls by 23, that is number of days. So here comes our total number of calls per day. These are our assumptions which we were provided by in the data set or beforehand. Total number of working hours, we are assuming that it is 9 hours per day, which contains 1.5 hours of lunch. Lunch hours are deducted from 9 hours. The time left by each agent working time is 7.5 hours, out of which 4.5 hours, only 60% of 7.5 hours, an agent is able to answer the calls. So here is the total number of calls coming per day. Here is the average calculated the time required to answer 90% of calls in hour. Here is the average time taken to answer a call. Here it is. Time required to answer 90% of calls. We we multiplied these two values, B40, total number of calls per day and average average time to answer a call with 0.9, as we are required to take the answered calls equal to or more than 90%, and then divided by 3600 to convert it into hours, from seconds to hours. So by dividing this value by 4.5, that is the total occupancy per day of an agent, we get this value, that is the 57. Like we require, this is our final answer. In a way, this is an answer that we require 57 agents to achieve the target of 90% answered calls. Like here we can see that calculated the number of agents required by dividing the time required by occupancy. Here I have mentioned all the steps one by one which were followed during the task. Calculated the agents required for each time bucket by multiplying the total number of agents required by percentage of calls for each time bucket. Here it is. I have copied this pivot table values here. Here are the percentage of total values for each time bucket of count of calls. We will multiply this percentage with the agents required. So for each time bucket, we will by multiplying this value with the agents required to get the number of agents required for each time bucket. Here are the number of agents in rounded off values for each time bucket, and this value comes to equal to 57. Here you go. Now coming on, these are the values and insights which were present in the Excel. I have pasted these values in the presentation also, so that the stakeholders can have a look at these values. Now coming on to the fourth task, this is somewhat similar to the third task, but here the difference is we have to find the total number of manpower required for the night hours. So along with the abundant rate with less than or equal to 10%. So for this, I created a new column day, which contains day of month with the help of a day function. Here comes the Excel visual. So this is a days column. With the help of day function, I got the values of day of month. From this column, I extracted the day of month. Now coming on to the second step, created a pivot table for each month, each day of month as rows and count of calls of separate call status in values. Here it is. Here is a pivot table. For each day of month, I calculated the count of calls for each call status for each day of month. Created another pivot table with aggregated values of average call duration for answered and transferred calls. For each call duration, for each day of month, I calculated the average call duration for answered and transferred calls only, and filtered out abundant calls. Now the third, fourth step, calculated expected number of calls during night hours by calculating the So we have been provided by initially that the expected number of calls during night hours are the 30% of expected number of calls during day hours. So these are the total number of calls during the day hours. These are the total number of average calls per day during day hours, day shift. And this is the value of total number of average like average time taken in seconds to answer a call. These two values which we have like calculated from these two pivot tables. Also, we calculated these values here in our previous task also. So for night shift, the total number of expected calls will be 30% of this. That is 1539. So the hours required to answer these calls at night will be 76.25. We will round off these values later on if required. So with the help of this value, like as we did in the previous task, we will be dividing this value, the hours required for the night shift calls by 4.5. Here it is 4.5 to get the number of agents required during night shift. So for each time, like coming on to our presentation again, calculated the time required to answer 90% of calls. I have shown this in Excel sheet. Calculated the number of agents required by dividing the number of required time required by occupancy time. I have shown this in Excel sheet as well. Calculated the agents required for each time bucket by multiplying the total number of agents by percentage of count call for each time bucket. Here comes our Excel sheet again. This is the call distribution for night shift for each time bucket in the night shift. This call distribution has been provided to us beforehand. This is the time distribution. That is the like ratio of total number of ratio of time, like ratio of values for each time bucket against the total by by dividing it by from the total number of percentage of calls. So by multiplying this value with our a number of agents which we got, we will get the number of agents required for each time bucket during the night shift. By rounding off these values, we were getting these values in decimal form, so I decided to round off these values. So by rounding off, we get a value of 19. So we can conclude that the number of agents required between night hours will be between 17 to 19. So coming on to our presentation again, here are the values which were present in the Excel sheet as well. I have pasted these values here so that the stakeholders can have a look at this. I'll be sharing the Excel as well as the presentation as well as the Jupyter notebook as my like submission. So coming on to the results, the insights which I gained and the inferences which I gained from this presentation from this project and the analysis of the data are as follows. The organization needs to add 17 to 19 support agents to tackle the night shift. The organization needs 57 support agents to achieve the target of 90% answered calls during day shift. Few changes are required in the shift of the staff if possible. Some day shift support staff can be shifted to night shift. The calls received during evening shifts are less, therefore the company can shift these staff to peak hours like morning and afternoon. Some morning shift support staff can start working early, like they can start working as early as 5 a.m. instead of 9 a.m. The organization should look to create 3 working shifts for each day to provide 24/7 service to the customer, to its customer. So these I will be concluding this presentation now. These are the insights and inferences which I got from this presentation. I'll be sharing these files as my submission to the Trinity team, and I hope I have done a good job in this project. Thank you very much.